So Jane is with the Cape Town Science Center, which is here in the Western Cape, just outside Cape Town CBD. Is it in Woodstock? What is that place, by the way?
Yes, observatory.
Observatory. Okay. So her topic will be electric circuits, which will mostly be relevant for grade 6 in term 3. But I've got no doubt that grade 4 teachers, grade 5 teachers, and grade 7 teachers could take something away with them that could be useful for them. So she will have the next 30 minutes with us. And a brief description of her topic goes like, a lesson on the key concepts of electric circuits for grade 6s. Within the lesson, she will be showing a hands-on demonstration on connecting an electric circuit and how we could go about it, perhaps with our learners. That being said, I hand over to you, Jane Claire. You can share your screen.
Thank you. If I can just get up into the presenters, then I can get ability to share my screen.
Let me get you sorted with that. Younger just stood up. Let me look for you in this list, Jane Claire. Yes. Make presenter. Okay.
Nice. Thank you. Just give me a second. There we go. Okay. So thank you again for the invite as well. I am excited to be sharing a little bit of knowledge with the teachers that I have joined for this lesson. Just a little introduction about myself. I am, like you mentioned, Jane Claire. I am from the Cape Town Science Center. I am a science communicator at the Science Center. So so we deal a lot with learners from primary school, but also in high school. So today I just thought to focus on the electric circuits for the grade 6s. And this type of topic is something that could possibly be overlooked. It seems simple enough for learners to understand, but it's best if the teachers also understand the concept quite well and so can explain the concept nicely to the learners. So I'm going to go through a few points on the topic, and then thereafter I will do the hands-on version of the experiments. Okay, so for electric circuits grade 6, I thought to just quickly jump back to grade 5 to recap. I know some of the learners, when the next year comes, they kind of forget grade 5. So for the term 3 of the grade 5, you guys do touch on the topic of energy and electricity. And the main idea that we like to show the learners the difference between the cells and the batteries. So we know that the energy is stored in these components in the electric circuit, and that is actually what gives the electric circuit the power. So it's important to actually understand what are cells and what are batteries. Okay, so for this, I know some people can get a bit confused, but I found this nice little image over here that can actually describe the difference between a cell and a battery. Now, I know a lot of the learners always think that the battery that we're using, if we use one AA battery, for instance, that is one cell. But actually, if you open up that, you do see multiple cells filling up that battery. So that is where the concept of a single cell, which is a single unit that stores chemical energy, which is what you see on your left, which is the coin battery. That is what we call a cell. And then the battery is actually what we usually use, which is our AAAs, our AAs, our 9 volts, and so on. So that would be our battery when we're using electric circuits. So the circuit is essentially a system that transfers electrical energy to whatever appliance that we need to actually power. So furthermore, in grade 5, you will also touch on topics of main electricity, kind of touching on the source of electricity. And every time we ask the kids, where does electricity come from? They always say Eskom. So the Eskom is just one power station as an example of where electricity is generated. And so it is transferred to our homes from the power station. So the source of energy differs from power station to power station. So that is also important to explain to the learners that when we say a power station, it can be various sources of energy. So the Eskom that we do know, most of our Eskom power plants are fueled by coal. So it is a coal-fired power station. And a topic also that you will need to explain is how does this fuel actually go from from coal all the way to electricity. So we can take the learners through step by step how the power station actually generates from coal to electricity. A lot of the times when we get the learners at the center as well, we ask, so how does coal become electricity? And a lot of them just stare at you with blank faces, because the concept of turning coal into electricity is something quite big to grasp. So I have a little picture over here, which I think explains a nice flow of the power station. You don't have to go in too much depth into the whole workings of the whole plant, but the main steps we like to follow is the step by step all the way from coal to the transmission, essentially where the electricity is from. So if I look on this picture over here, so our first step is the coal. So we obviously have coal as our fossil fuel, and the coal is pulverized or crushed, and then it is heated up in a boiler. So an example you could use here to make the kids understand a bit better. A lot of kids do know when you are perhaps having a braai, you do burn some coal and that coal gets hot, right? So they can understand or relate that to something that they kind of used to. So when the coal gets warm, in the boiler, it has water tubes running around it, and water actually gets hot because of the heat from the coal. So we have a transfer from heat of the coal to the water. When we get to the water heating up, we need to ask the question, what happens to water when it gets warm or when it heats up? And an example you could use there is the kettle. So when the kettle is boiling, we have to observe what actually happens at the top of the kettle. And of course, the learners will know that steam is actually coming on top of the kettle. So when the steam is coming up from the water, it is basically flowing at high pressure and speeds over a turbine. So the steam turbine has these sort of blades that is pushed into a circular motion. So the turbine turns round and round because of the force of the steam coming out. The turbine is then connected to a generator, which is a electromagnet surrounded by a copper coil, and that is causing the flow of electrons to come off, and so electricity is actually formed. Now, this concept does seem like it is on a small scale, but we always like to show the kids just how big these type of stations can actually be. So part of that station, which is the steam turbine, if we take a closer look at the steam turbine, you can see just how massive the steam turbine is. Now, showing kids this type of imagery gives them a grasp at just how much coal is actually needed to power that station. The steam turbine is quite large. You can see the men standing underneath it, the difference in scale of the size of the turbine compared to the men standing at the bottom. That means you need an immense amount of steam to actually turn that turbine. So this also can form into a discussion with your learners as to why coal as a source of energy might not be the best solution, as seeing how much coal you actually need. That always surprises the learners when we do show this picture. They always think that it is on a smaller scale than what it actually is in reality, which is always important to show the kids just how in real life what actually is going on at these power stations. Right. Now I'm going to jump over to the simple circuit, which is a little bit of the theory for the grade 6, their term 3 topic. So when we talk about a simple circuit, it looks something like this. So for them starting out, they won't do a very complicated circuit. It will have the battery as your source. It will have the light bulb where the electricity is going to. And of course, they do need to be connected. And a switch is also important. A lot of the times, a circuit is drawn without the switch. But I think it's important for the learners to be aware of the switch and the function of the switch itself. Now, this picture that you're seeing over here is a real life image. So a real life battery, real life light bulb and switch and so forth. For the learners, they will need to also be taught on the circuit diagram itself, which will be used to depict our parts of the circuit. So if we're looking at the diagram of this circuit, it will look something like this. So instead of the battery, actual drawing of the battery, we will have these lines. So the longer line would be our positive, smaller line would be our negative. So for the battery, it is going to be two lines, one big, one small, and then repeat one big, one small line for the battery, as it is a component of two cells in this example. Then we have our switch over here, also important symbol to note. It is a open switch in this image when it is lifted up. And then we have our light bulb symbol, which is a circle with a cross inside. The light bulb symbol is the most basic component of the simple circuit that we do with the learners when they're starting out. There are some other devices that you could input over there, which the symbol will change. And I'll show you a little bit some other symbols if you do try and expand a bit to other electric circuits. Okay, now when we teach the learners the circuits in this manner, sometimes they struggle to identify the components of a electric circuit. So they might be able to name the battery, they will name the light bulb, for instance, but when we teach the simple circuit, it is important to show them that they are actually just four components. If we break it down into those four components, it becomes a bit more easier for them to grasp. It's only four components that they are connecting. So I like to put them in a table as you see over here. So they could see the four of them sort of disconnected. So we have a battery over here. We have the device, which is our light bulb. Then we have our switch. And one of the components that they sort of overlook a lot of the times is the connecting wires or the conductors, which would be the actual terminology. So a lot of the times the learners will think there are only three components. If we just to show this circuit over here, it looks as if there are only three components in that electric circuit, but in actual fact, there are four if you consider the conducting wires as part of the electric circuit, which it definitely is. If you connect the battery, or you would not actually have a means to connect the battery with a light bulb, also with the switch, if you don't have the conducting wires. So I think it's important for us to highlight that when we are going through the electric circuits components, to mention the four complete components in the circuit. And then just again for the symbols, it's important when they are drawing the electric circuit to use the symbols as it is like that on the screen. Of course, the wire is the simple connecting lines that connect all of these components together. Now, I want to talk a little bit about the switch. A lot of the times we see people connecting the battery with a wire to the light bulb. And of course, the light bulb will go on, right? It is a closed circuit. It's not unbroken or anything. So the light bulb will go on. But I think it's important to show the function of the switch. I like to use the example of in the classroom where we have the switch against the wall. If there was no switch against the wall, how would we have to disconnect our lights from the battery or the power source. That means we actually have to go and pull the wires with our hands if we wanted to switch the light off, right? So the switch over there is important to control the flow of electric current. So if we don't have a switch, it becomes a lot more dangerous and not safe when we are using our electric circuits. Just a little bit on the symbol there. It's important to note when it's an open circuit, that means the switch is off. Then the line is facing up. And if it's closed, that means the switch is on. You could think of it like a gate. So if the gate is open, that means electricity can't flow through. Whether if the gate is closed, connecting those 2 points, that means electricity can flow through them over there. Okay. I think that is basically the theory on the electric circuits, the simple circuit. It is, like I said, sounding simple, but if we take our time and break these 4 components down to their individual parts, it makes it a lot more sensible for the learners. Another added point to add on to this is the function or the role of our battery and our device. So our battery, we like to call our input energy or our input source. So that means that any power or any electrons that need to be added into our circuit, which is the flow of electricity, that means that is coming from our battery. On the other hand, our device is our output energy. So the device can be a light bulb, like in this example, but it can also be a buzzer or a fan or a kettle or any type of appliance that would take electricity out of the circuit. So that is also something that the learners don't quite fathom very well. So it is taking in electricity or taking in energy from the battery, and then the light bulb or the device will be taking energy out of the circuit. Okay. So these are some other symbols that you might need to use. So we have our basic ones, which is our battery, our wire, which is a straight line, switch off and switch on. The other symbols are the output energy symbols. So we have our light bulb, which is the circle with a cross. If you were to use a buzzer, you would use this symbol over here. Or if you were to use a motor, which is a fan, you would use the circle with the M inside. Now, for the hands-on activity, I would like to show you guys how we build our electric circuits with the learners at the Science Center. Now, these do take electric components, but there is another way that you could use, you could use consumables around the house to actually make a electric circuit over there. So I'm going to go through, I'm going to stop sharing, and then I'm going to switch to the camera just to show you a bit on our hands-on electric circuits. Before I go much further, is there any questions regarding the theory of the electric circuits, regarding the 4 components or the symbols or anything like that? Can
Please feel free to unmute your microphones, colleagues, and ask the questions.
If you are all good, you could also just give me a thumbs up or a reaction. Then I am all good to go on. Okay, thank you. I see the thumbs up. Thank you. Okay, so I have brought a electric circuit that I have made over here with some components. Now I am going to switch to a different camera so that I don't hold it up like that, as the components can sometimes be a bit floppy. Can you guys still hear me?
Yes.
Oh, okay, perfect. We're just hoping the camera didn't take out my mic. Okay, so this is how our simple electric circuit would go. Now, what I've done here is I've just used a cardboard sheet. You could use anything, a book cover or anything like that, or even the tabletop, to lay out your components. A lot of the times we see, say, these things are not pinned down per se, and they kind of circled like that. That is when we notice the kids are drawing their circuits with curved lines for the wire. It is essential that we make sure that they understand the wire is a straight line going around the components. Of course, in the real life, it won't necessarily look like that, but when we are building electric circuits, I like to make the lines quite sturdy and straight to actually show the path of electricity when the circuit is connected, right? So for my circuit, I have just simply stuck down the components with a little bit of the plastic over there. And then what I have over here is a light bulb holder. I can just show it a little bit closer to the camera. So the light bulb holder looks something like this. It has two parts on the side. So there's one over there and then there's another one over there. And it is connected by a simple wire. This is a main copper wire. And the light bulb actually screws out over here. So you can replace the light bulb and the holder over there. Now these components, along with the battery holder, they are readily available for purchase, and they are not too costly. I know it is a bit difficult for teachers to actually get supplies for building a circuit like this. I have checked, and where we buy our electric circuits, that would be at places like Builders or Communica. For instance, the battery holders would go for about 10 Rand each, and the same with that. So they're not too costly on their own. I would hope that if you could at least get a few in your room to demonstrate something physical to the learners, the ideal thing would be for the learners to each have or at least work in pairs to build their electric circuit. But for now, I am going to demonstrate over here. So these two over here, these wires, I'm just going to twist them around each other to make sure that they are connected. Okay, and what we have over here, I'm actually just going to touch them to each other for now. And then on the other side, I have these two paper clips. Now, if we don't have the paper clips, we would have to make a similar connection like that one over here with the two wires. But the paper clips over there is important to show the role of the switch. So the paper clips are made of metal. You might notice you have paper clips that are covered with color. Maybe they are pretty colors, but for the electric circuit, we like to use the plain paper clips because they are not covered by any plastic that will actually insulate. So once I tap these two paper clips to each other, that closes the circuit and the light would go on. The paper clip goes off and the circuit is open. Once the paper clip closes, it closes the circuit. Now, I think with the paper clips, adding the paper clips into your electric circuit, it does add a nice aspect of closing and opening a circuit. Whereas just connecting your light bulb straight to your battery, that won't really tackle that concept of a switch. Okay, so with this circuit, I know, like I said, you'd have to buy all these components, which can be quite tricky. I have found, or we have started to use some kind of electric circuits that don't necessarily need that much components that you actually need. So I'm going to slide this one out the way and I will show you my other circuit. Okay. So what I have over here is a simple circuit once again, simply with an input and an output. But instead of the connecting wires, I've actually used some aluminium foil. Now, the foil is a very good conductor of electricity. So it is a simple material that you can use to actually do an electric circuit. Now, I'm just going to demonstrate quickly how it works, but I will be showing you exactly how I put all of these together. So once I put the battery over here on these two parts, it turns the light on. Now, you might notice that I am lifting and dropping this part over here. This section over here, which I have not stuck down, acts as my switch. So you could see the switch is open, which means the electric circuit won't go on. And if I close the switch, it goes on. So this simple circuit can also show the basic concepts of our electric circuit. Okay, now I'm going to do my hands-on version. So let me take these two parts over there, and then I'm going to bring a new board in. So for this circuit, you would need a board. Again, you could also just use the table. And then you would need a 9-volt battery like this, which would have the 2 poles on the ends. That just makes it easier to close the electric circuit. And then we have a light bulb without the light bulb holder. So you wouldn't need to purchase much, just the light bulb and the battery. So hopefully this is a bit more accessible to your learners and to yourselves as well. Right. So I'm going to go into how I put this together. So for the starter, you could start without this step, but I think this step makes it much more easier to build the circuit. So what I've done is I've drawn a complete electric circuit using my circuit symbols. So I've included my light bulb. So this will indicate the position. Then I've included my battery position as well. And I have drawn my switch. So this way I now can plan where I'm going to put the foil, which will cover all my conducting wires, and where I will leave space for my electric circuit components. Okay, so let's get to that. So I have some foil over here, and I have just cut a few strips over here. It doesn't take that much foil. So for instance, this one you could paste down like so, but if you want to make it a little bit neater, you can also just fold it into a little strip that actually fits onto the line of your conductors. So very easy. You could either use some press stick just to keep it down. You don't need to keep it down quite necessarily, but it does make it a bit easier when you are moving things around that these parts actually get stuck down. So I'm going to take a little bit of sellotape and I'm just going to stick down the ends of it, and pulling it straight also helps just to give that straight view of our conducting wires, right? We don't want anything to be curved to show a wrong circuit. So the next part I have to do is my light. So for the light, again, I'm going to take this piece and just fold it in half. It's not completely necessary. You would actually use a lot less foil if you did not flip it over. So you would actually need half of this foil that I'm using. So for the light bulb, if it covers the drawing that you've made, you would need to just move a little bit away from where your drawing was, just to give a little bit of space for your light to actually fit in. So I'm going to stick this one down over there. I'm just going to get some sellotape. Now, when you are putting the sellotape on, make sure that you're not putting the sellotape all the way over this end, because we want the light bulb to actually touch the foil itself. if it's touching the sellotape, that does cause a little bit of a disconnect. So make sure you leave a little bit of space of the foil that is left open. So I've stuck the sellotape a little bit back. I'm just going to stick this corner down as well to make sure that these two parts are actually touching each other. Then I'm going to move on to the next section for the other side of my light. And I'm going to stick it down here. Now, you could also just plan and measure just how far you actually have to go. So I'm going to stick that one down over there. Again, leave a tiny bit of space between your sellotape and your foil so that these two parts on the inside is foil and foil. I'm going to stick this one down. I might just need a small piece. Okay. And now for the next step, which is the switch over here. I'm going to stick this one down, going all the way to the end of where I've drawn my switch line. So I'm just double checking the measurement there. And then I'm going to fold this once again. And then I'm going to stick that down over there. So this is quite a simple and easy task for the learners to do. I don't think it is too complex in terms of building, but it does give them a bit of control as to how the circuit is actually built. So this helps them sort of follow and know where exactly the electricity is going to flow. Right, for the next step, I'm going to add my switch. Now the switch, I need a little bit of a longer sheet of foil that goes just a little bit over this part over here. So I've got the piece over here. I'm going to fold it. And then I'm going to stick it down on that end. Okay, that's good. And then for this side over here, to actually make the switch open, I have to lift a little bit of the foil so that it is not touching the other side before I actually want the circuit to go on. So foil is such a nice product to use because you can just fold it and it easily molds to where you want it to go, right? So I've just made a little fold over there so that the switch lifts up like so. And then I'm just going to stick this part down. So the only part that is really down over there is this part over here, but we are going to leave a bit of the foil sitting up. So that way, when I close it, it covers the other section and it actually touches. It's important that it touches the other side of my switch, which is the side. Right. Now for the last part of my circuit, which is the battery section over here, we know that we have to get these two poles to actually touch 2 points of our foil. We cannot let the foil overlap in that way because then the current won't necessarily flow in one direction. Okay, so I'm going to fold this piece in half once again. Let me just show you. And then I'm going to lay it down like this. Now, this one is important to measure the distance between my positive and negative pole so that I could make a gap between the foil between these poles. Remember, we don't want the foil to actually touch in the middle of these two poles. We want the electricity to flow in one direction all the way to the other pole. So while I am planning that, I'm going to stick the ends of my foil down So we know that position is fine. So I'm going to put one over there. And then I'm going to add another one on this side. So once we have it like that, all I have to do is just take a look at where my two poles. So I have one pole over there and another pole over there. So I'm going to make a little slit between these two poles. So I will cut the foil completely through. And just to make sure, let me just turn it like so. Just to make sure that these two are completely not touching, I will fold the piece up a little bit to make some more space. And I will fold this side a tiny bit up as well to make some space. Okay, so now if we just take a closer look, we can see that we have a little bit of space between these two where our poles will actually touch. So you can see I've tried to align them nicely when I place them down. Okay, so for now, if you want to neaten it up, you can sort of take away any of these edges. Right now, it's not quite crucial, but I'm just going to snip a tiny bit away just so that it doesn't overlap. And if any pieces are still jumping up and not laying nice and flat, I'm just going to add another piece of tape I see over here. All right. Now my circuit is ready to be used. I will put my light bulb at the position where I initially made it. And this light bulb over here has these two metal points. So I just have to make sure that my metal points are touching the two ends. So let me see if I can lift it closer. So the metal points over there is touching that side and that side. If it's not touching completely, that means the electricity won't be able to flow. So now that my light bulb is in position, I'm going to take my battery. Again, this is a 9-volt battery. And I'm going to push it down onto the foil. Maybe I should use this hand. I'm going to push it down onto the foil. And now, taking a look at my light bulb, I'm going to close my switch and the light will go on. If I take my hand off, that means I'm opening the switch, stopping the current from flowing from this point to that point. And when I close my switch, the light actually goes on. So I think this is quite exciting when learners see just how simple, with a little bit of materials to be used, you can actually make an electric circuit. And this way you could add some other components in as well. The conducting wires can work with any electric circuit in that regard. Right. That is the electric circuits in a nutshell. I hope that you guys have learned a little bit and hopefully will make use of these types of techniques that I've shown you to make the electric circuits a little bit more accessible for you and your learners. And I'm sure they will have a lot of fun actually putting all of this together. We do see that at the Science Center as well. A lot of them do enjoy working with their hands and making things sort of from scratch. Is there any questions for me at this time? Thank you, Nadima.
And if there's any questions, colleagues, feel free to just unmute your microphone and go for it. Or if you've got a comment, please feel free to unmute and make a comment. It's our space, it's everyone's space. It's a safe space.
You guys can let me know, what do you think about these two electric circuits, if they will work in your classrooms?
What do we think about the ideas?
I love the ideas. I really do love the ideas. Thank you. They're fresh. They are doable. It's easy obtainable as well. And I'm definitely going to give it a try with the grade 4s even. Because
Yes,
I
definitely.
introduce the simple circuit to the grade 4s, especially when I have to do the input and output of energy. Because it
Yes.
helps to understand that. So I'm really going to try your foil idea. Thank you very much.
Awesome.
Very
Thank you.
fresh.
You're welcome. Thank you. Actually, another part that you could use, or a way that you could use these electric circuits, is when you are talking about insulators and conductors of electricity. So instead of the paper clips adding to close the switch, you could use things like a piece of foam, which is not conductive, or you could use a nail or string and just actually test different materials to see if the light goes on, that means it is a metal. If the light does not go on, that means it's a non-metal. So that's a different way that you could actually just mix electric circuits, and I like that you're also adding it in with the grade 4s.
That is really a good idea. Because normally we would give them the little components to put together to test for insulators and conductors and have a little money bag with all the little items in there. And then they
Yes.
would complete their table by filling it in if it's an insulator or conductor. But I like the idea by putting it onto something firm and then putting the component in between, because then it's more much more sturdy, and they will see the effect immediately as well,
Yes.
everybody in a group.
Yes.
Thank you.
Yes. Yeah, thank you. You're welcome.
I was just wondering about the battery that you used.
Mhm.
Is it working the same if you just use an ordinary battery or a cell?
Yes. So let me see if I can show you like this. So for instance, where I had my battery over here at this point, I was using it like so. But if you were to use a normal battery, let me just get one out. I have seen people use the normal battery by just laying it between these two. But now remember, the poles of this battery is on the ends of it, which makes it a little bit more tricky because you would need to raise this piece of foil up so that it can actually touch the pole. Does that make sense?
It does. If
Yeah,
you maybe
yeah,
stick
yeah.
it down with a piece
So
of
the-
tape, Sandra.
Yeah.
Put a
Yeah,
So
piece
the
of
yeah.
pole
tape
this
down.
side and that side.
And lift it up like that, then it can work. Because I'm just
Yes.
thinking the other one that you're using is quite expensive.
Yeah,
Oh, the 9 volt. Yeah.
yeah. In the rural areas, those are not very obtainable.
Obtainable.
Mm.
Yes.
Yeah, yeah,
Yeah.
yeah.
Definitely.
Okay, cool.
Yeah.
Thank you very much.
Thank
I
you.
really
Thank you.
enjoyed.
Yeah,
Awesome.
me too.
Thank you.
Me too.
Okay. Any more comments, colleagues? We need to give the last speaker a turn to shine. Any more last words, last comments, last questions?
Okay, thank you, guys.
Okay, it's all hearts and thumbs ups and
Yes.
clapping hands, which is so beautiful. Thank you.
Thanks.
Thanks to you, Jane Claire,
You're
and
welcome.
for taking the time to be with us this afternoon. And we hope we will have more times like this.
Thank you for the invite.
Thank you. You are welcome. We'll be in
Thanks.
touch thereafter.
Sure.
Okay, cool. Thank you so much.